In this video, you'll be learning about finding the arc length from a function. Now, the arc length formula is the integral of the square root of 1 plus dy over dx squared. Okay, and our function we'll be using for today, or our first function we'll be using is 4 times x to the 3 over 2 power. Now, as you can see here, we have dy over dx in the formula, which means we have to take the derivative of this function here. And the derivative will be equal to 6 times the square root of x. Okay? And then now, when you plug everything in here, one more thing. For arc length, right, you need bounds, because if you don't have any bounds and you go, for example, from 0 to infinity, well, the arc length would just be infinity then. So in this case, we'll just go from 0 to 2, so that we have a valid answer. So to take the arc length from 0 to 2, okay, you would have to do 1 plus, and then, well, 6 squared is just going to be 36, and then the square root of x squared is just going to be x. So this is going to be 36x dx. Okay, and then now we want to make u equal to 1 plus 36x, and then du, right, it was going to be 36 and then dx here. Okay, so when we substitute for dx, we're going to have 1 over 36 times the integral of, we don't put the bounds yet, times the integral of u du. Okay, so here, the reason I didn't put the bounds is because we're in terms of u, but yeah, once you convert back into x, I'll put the bounds back in. So now, right, this will be equal to 1 over 36, and then what is the integral of the square root of u? Well, that's just going to be 2 over 3 times the quantity u raised to the 3 over 2 power, right? So, well, u is anyway 1 plus 36x, so we'll just plug it back in now. So 1 plus 36x, okay, and then all of that to the 3 over 2 power. And then now you want to take this from 0 to 2. So now I put the x values back in. Okay. So this means that our answer is going to be, well, it's going to be a pretty long answer. So yeah, okay, yeah, so basically it's going to be, I'm going to write this in an expanded form, but if you want, you can simplify it. But for the sake of this video, I'm just going to write it in a expanded form. So in the expanded form, it's going to be, well, 36 times 2 is just going to be 72, and then 72 plus 1 is just 73. So it's going to be 2 over 3 times 73 raised to the 3 over 2 power minus, well, 36 times 0 is just going to be 0, and then 1 raised to the 3 over 2 power is just 1. And then, right, and then we're just going to have 2 over 3 times 1, which is just 2 over 3. Okay, and this is our answer. Right there. Alright, time for the next one. Alright, for the next one, we're going to be doing y is equal to 2 over 3 times x squared plus 1, all raised to the 3 over 2 power. Now, before we do anything, right, remember, you have to take the derivative of all of this. Now, the derivative of all of this is just going to be equal to x squared, remember chain rule, all raised to the 1/2 power, right, because we do 2 over 3 times 3 over 2, which is just 1, and then 3 over 2 minus 1, which is just 1/2. Now remember chain rule here would have to make, would force us to take the derivative of x plus 1. And then in this case, we're going to have all this times, right, the derivative of x plus 1, sorry, x squared plus 1 would just be 2x. Okay? So now, right, we can write this a bit better, so I'll just write this as 2x times the square root of x squared plus 1, okay? So now we plug this back into our integral, and we'll make the bounds from, let's just say, 0 to 1 this time, right? Just to make it more simpler. So when you plug all this back in, we're going to have 1 plus, now, our dy over dx, this is our dy over dx here. Oops, let me recirculate that a bit better. Right, this is our dy over dx. So when we plug that back in, we're going to have 2x times x squared plus 1 all raised to the second power. And then now, I'm going to simplify this a lot further, right? And, whoops, it's supposed to be 1. And then now we're going to get 1 plus 4x squared, right? And then 4x squared times x squared plus 1, okay? Remember that you're timesing x squared plus 1, that quantity times 4x squared, since you wrote it like this, right? Because the 2x is outside the square root, and now as a result, if you times 4x squared by the term x squared plus, and then by the term 1, okay? So when we do this, when we write all this, okay, we're gonna have square root of 4x squared plus 4x to the 4th power plus 4x squared plus 1. Now you might be thinking here, how exactly are we going to be taking this integral here? Because it's, yeah, as you can see, at first it might look like you can't really do anything, but actually you can. The thing is, if you remember that this whole thing here is actually a perfect square. You might be thinking, well, there's no way it is. Well, actually, remember that 2x, let me write that a bit better, 2x squared plus 1, all that squared, will literally give you what's inside here, inside the square root symbol. So if you factor all this out here, you're going to get what's inside the square root symbol. Okay, so yeah, I guess for this approach, just try and see if it's a perfect square. So that way, you can simplify your integral a lot. Okay, so when we make this a perfect square, now what will happen? So let's see what happens now. When we make this a perfect square here, you're going to have 2 times x squared plus 1, all that squared, times dx. Now, surprisingly here, the square root and the 2 here, right here, cancels out, right? Because 1/2 times 2 is just 1. So we're going to have from 0 to 1, 2x plus 1 dx, alright? Now, as you can see here, all we have to do now is just take the integral of both terms, so 2x squared, 2 times x squared plus, and then take the integral of 1. So when we do that, we're going to have 2 over 3 times x to the 3rd power, okay? Yeah, and then, yes, because 2 over 3 times 3 would give you 2, and then 3 minus 1 would give you 2. and then you get that term right there. Okay, and then now the integral of 1 is just going to be x. And then now if you evaluate this, and this right here will be your answer. Yeah, and then once you evaluate though. Once you evaluate it, it'll be your answer. So now, right, if you plug in 0 here, you're just gonna get 1, whatever we plug in 1 minus 0. So we don't really have to like worry about the 0 here. So yeah, we don't have to worry about the 0, and we can just plug in 1. So when we plug in 1, we're gonna get 2 over 3 plus 1. And now what will this give you? Well, 3 over 3 plus 2 over 3 is just going to be 5 over 3. Okay, and that's your answer. Oh yeah, one more thing. You might think here, well, we're trying to solve for arc length, so shouldn't there be units? Well, yeah, there can be units. So here you can just put units here, but if they say like the graph is measured in meters, then you'd put like 5 or 3 meters. But yeah, but usually it's just going to be, your answer is just going to be 5 or 3. So you don't have to worry about putting units and all that. All right, so that wraps up the video, and I'll see you in the next one. Thank you.